Hi, I'm Neville Modise, and my research title is an empirical study on different feature selection and classification algorithms for diabetes prediction. Diabetes is one of the deadliest diseases in the world. Having diabetes impairs your body's ability to generate the hormone insulin, which leads to improper carbohydrate metabolism and elevated blood glucose levels. According to our research, over 4 million adults in South Africa are affected by the condition, and just under half of people living with diabetes in South Africa are undiagnosed. So 1 in 9 adults in South Africa have diabetes, and 1 in 10 adults around the world have diabetes. Even though diabetes can be cured, there are several effective treatments that may be used to lessen its negative effects. One strategy to mitigate this is to build risk prediction models, in which undiagnosed diabetes can be predicted from various recorded factors. We can use feature selection to extract important data from patient records in order to narrow down the most important risk factors to establish a more precise diabetes diagnosis. In medical applications, feature selection aids in the comprehension of illness pathogenesis. Therefore, the aim of this study is to determine the best methodological framework for better diabetes prediction by combining feature selection and classification algorithms. The collected dataset for this study is from the Behavioral Risk Factor Surveillance System and has a total of 253,680 entries. And in addition to the target feature, the dataset has a total of 21 features. For example, the 21 features include BMI, which is body mass index, age, high blood pressure, which represents whether a person has high blood pressure or not, and many other features. Feature selection, of course, is the process of identifying and eliminating irrelevant features or risk factors from our dataset. So we used two feature selection methods, which are chi-square and mutual information. Then we also used four machine learning classifiers, which are SVM, k-nearest neighbor, random forest, and logistic regression. And now for the performance evaluation, we used accuracy, precision, and recall to evaluate the performance of each model. Our methodology or experimental process started with finding a dataset and pre-processing it. Then, the most important features were identified and selected by using the two feature selection methods. This resulted in two distinct feature subsets. Each of these subsets, along with the original dataset, were fed into four different classification algorithms. The reasons for using four algorithms is to ensure that the models are derived using different feature selection schemes. Once the models were derived by the classifiers, they were compared using different evaluation metrics to report their effectiveness in predicting diabetes. Moving on to the feature selection results, we start first with the chi-squared feature selection. We can see that the features are visualized in terms of their chi-squared value. So a simple method of selection is to rank the features by their chi-squared value and choose the top 5 ones. So in our case, the 5 most important features obtained using chi-squared were found to be physical health, mental health, difficulty walking, general health, and education. So we will refer to them as the chi-squared subset. And now we move on to our second feature selection result, which is the mutual information subset. So as we can see from the graph, the top 5 features with the highest scores were found to be general health, high blood pressure, BMI, age, and high cholesterol. So we will refer to these features as the mutual information subset. So these two tables contain the listing of the chosen significant features by their feature selection method. So we can see the chi-squared subset on the left and the mutual information subset on the right. The tables also demonstrate that the two methods pick distinct features with only general health rated across both feature subsets. This indicates, at least statistically speaking, that these features are the most significant or important in predicting diabetes. The outcomes of applying feature selection and extraction to our diabetes dataset were highly dependent on the classification technique used to build the model. We will discuss the results in a later slide, but for now, we can see that the SVM outperforms the classifiers in terms of accuracy when using the original full feature dataset. Moving on to the results using the mutual information subset, we can still see that the differences in the results are marginal. However, the SVM still outperforms the other models in terms of accuracy and precision. And now, finally, the classification results with the chi-squared subset. We notice that the chi-squared models were outperformed by the models using the original full feature dataset and the mutual information subset. Let's now discuss our results. So we notice that the models constructed on the original dataset outperformed all the models created on the chosen feature subset. But in some instances, the differences were marginal. We found that the SVM algorithm, when applied to the original dataset with all features, yields the most accurate and precise model. Notably, the models constructed using mutual information subset attain substantially greater accuracy than those generated from the chi-squared subset, but lower accuracy than the original full feature dataset using the same machine learning algorithms. SVM built the most accurate model of the two feature subset with 74.58% accuracy, 78.40% precision, and 73.5% recall, although the difference between the results were marginal. The scope of our study is limited since we only examined a limited number of machine learning and feature selection approaches. In a future project, it would be interesting to use a bigger dataset and investigate other possible pairings of feature selection approaches with other machine learning algorithms. So in conclusion, this research looked at how feature selection has been used in the medical sector recently, and the results show that it is a valuable pre-processing tool for reducing the amount of features while also providing an insight into the root causes of certain diseases. We examined two feature selection techniques, namely chi-squared and mutual information, as well as four machine learning classifiers, which are SVM, k-nearest neighbor, logistic regression, and random forest. The given models may benefit physicians and other medical professionals in isolating the most important features of a dataset, as well as establishing a more precise diabetes diagnosis. Thank you for watching.